Hi, Form 4 students, it's Professor Danquitz, and hopefully I'm going to be able to demonstrate to you how to calculate the slope, the intercept, and the correlation coefficient using Excel. We're also going to use Excel here to demonstrate how to construct a proper graph. Instead of all the number crunching with the standard deviation of x times y and the standard deviation of x squared and the intercept and all that, that takes you maybe about 20-30 minutes. This will take you 5 minutes exactly once you get used to it. So let's hope we can sort it out for you, and this is probably the best way to do it for you. So what we put in number 1 is our data. So we're going to put in time. Actually, we're going to do a graph of log of RV concentration versus time. Forgot to tell you that. So you normally supply it with time, data, and then they take blood samples at certain time intervals after IV injection, and they could take it 1, 2, 3, 4, and maybe a last one at 12 hours. And the concentrations will just make them going smaller and smaller. 1, 2, 3 hours, about 98, 12, about 82. Oops. And let's just put a 6 hour in there. 6 hours. 54 and 12 hours. Make it a small number that it's almost at its end. 14. So those are RV concentration and these are time. Now we want to do log of RV concentration versus time. In this case, time is the independent variable, and the independent variable is always on the x-axis, and the dependent variable, the RV concentration, is a y-axis. And why do we say that? Because time goes on independent of the concentration. Doesn't matter what the concentration is, time carries on. But the concentration of drug in the blood depends on the time. As time goes on, the concentration changes. So concentration is dependent upon time, and it goes on the y-axis. Now let's do log of RV concentration. Just fill it in. We can put the cursor in the column there until the two that are splitting apart, move it across, makes it bigger. There you can fit it in. We can take those and make them bold, so the headings. Then we want to get log of 134. So you put it in log of RV concentration in the next block, empty block. Go to your functions, fx. Then you can see here's the log 10 anyway, but because I've just used it, but we can search for it. So we go, put in there log, and we say go, and it'll give you the options. That's log, returns a logarithm of a number to the base you specify. This IM log 2 gives you the base 2 logarithm of a complex number. Log 10, you should recognize, returns the base 10 logarithm of a number is what we want. Logs on base 10. Let's choose OK. And asks you for the number, and you can type in this case, B2, and or you can just highlight it like that, click on it, you say OK, and there it gives you the value. If you want to do for the rest, instead of putting in that, go fx and whatever we have to do, we just go to the bottom right hand corner to get a solid cross, right click on it and drag it down to C7, and these are all the log values of the RV concentration. So these we can just look a bit large. This can increase the decimals and this can decrease. We normally work to about 4. It doesn't look so busy either. 1, 2, 3, 4. That's it. Now we want to plot a graph of time on the x-axis and log of RB on the y-axis. So we normally choose the x-axis first. So we click on time, drag it down. Come on. Click on time, drag it down. Hold in the control button. Keep holding there. Put your cursor over log of RB. Right click it. No, left click it. I don't know why I'm always saying right click it. Left click. And drag it down. And choose. So now we've chosen time versus log of RB concentration. We want to put in a graph. So we go to insert. And it gives you the number of different type of charts here. Column, line, pie, bar, area, scatter, other. We want a scatter and then give you just the points, or on a smooth lines, or just the lines, or just the straight lines and markers. We'll do straight lines and markers. That's how the data is. And there's your graph. Whoa, well, it looked quite good. It's also given 5 decimal points there, but that's fine, and that's your time. And of course we don't have any labels on, which is not good for a graph. If you come from Potchefstroom University, that's fine, but if you come from Wits, we do it properly. So let's just expand, come on, expand it a bit, so you can see what's going on. So what we want to do is we want the axes labeled. And here we got type of chart layouts. Here you can change the color. Red, green, orange, blue, purple. Red's cool. I like red. Okay, then we go to chart layout. And here we've got a number of different ones. There you are. Gives you the grid, horizontal, vertical and horizontal lines. It gives you label for x-axis, y-axis. Gives you the legend which we don't need, or that one for example gives you no grid and gives you the actual numbers. Looks a bit silly, but you might want to use it. This one gives you just the horizontal, and so there's a number of choices here, but we'll go for layout 3 as we clicked in the beginning. Then we'll just label, so you click on it, double click it, delete, 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 backspace. This is log of IV plasma concentration, and we say it was in milligrams per liter. Okay, we click on y-axis title year, and this is time. And it's in, what did I use it? Hours. Time in hours. And there we have it. Legend. We only got one graph, so we don't need the legends. So we'll just say delete that. Now, instead of all this wasted space here, we want to perhaps make this graph look a little bit better. Take up more space. We can see what's going on. We click on the Y variables, right click, format chart. No man, I didn't want to format chart. Right click, no, come on, now I'm being silly now. Format axis, that's what we want. Just move it across so you can see. Now here we've got here the minimum values automatically 0, the maximum is 2.5, 0.5 is, so 2 to 2.5, 1.5 to 2 is a variable. The minor units there are all 0.1. If you want to change those, so you can see your values go from 2.12 to 1.1. I'm going to make it from 1. So the minimum, this time we can say fixed, not, no, 1.1, let's say 1.0. The maximum is fine. the major units are 0.5. We might want to have a few more so you can see a little bit more detail on the graph. So 0.2. Minor units 0.1, that's fine. Major tick marks, logarithm scale, nah. Everything else is fine. Enter, and there you have it. 102, 2.4. Then we might want to do here, instead of every 2 hours, we want to put hour plot. You can see now the axis, the x-axis crosses the y on 1 instead of 0. So we can choose format axis. This is the x-axis. We want it to go to north for sure. We might not want 14 hours. We can say we want 13 hours. And, yeah, 13 major units fixed. We don't want it every 2 hours. We want it every hour. And then you can do all sorts of other things there again. We really don't want to do anything else with it. So enter it, and there we have time in hours. Now you'll notice that in this graph it already has a trend line that's been put in because of that choice there of layout 3. So we can right click on the trend line, format trend line, and you can see you can do anything. You can give it an exponential, if it was that, linear, logarithmic, polynomial, all sorts of funny things, but it was actually linear. So we keep it as linear. Trend line name, automatic, we didn't need to know that. Set intercept equal to 0, that's fine. But we want to go back from 1 to 0. We want to find the intercept on the y-axis, or see it at least. So if we go backward 1 units, there we are there, backward 1 unit, going forward doesn't really matter. And we want to display equation on the chart, and we want to display the correlation coefficient squared. And say closed, and there you are. It's gone backward 1 step, and that's about 2.2469, which you can see from the equation. Move. That's the equation. The slope is minus 0.09 x plus 2.2469 intercept in the y-axis, and the r squared, the correlation coefficient squared, is 0.995. So it's all given to you there. If you want to calculate them without actually having to do the graph, you can do that. We can calculate the slope, so we'll put in there slope. We can actually put in there slope equals, click on an empty square, go to function, type in slope, go, there was the slope, choose the slope, OK, gives you known y's and known x's. So we can go again. These were the y values. We don't click on the heading, we click on just the values. So you left click, drag it down, and choose them. Come on. There, C2 to C7, known x's. In time, the x's of time values, C2 to C7. And there we have there. Just check it. So OK. And the slope is 0.9005, and that's what it says here, 0.09. If it's that many decimal places, and we wanted it to 4, then we can go and put in the intercept. Intercept equals. Just move that across so it fits in. Click on the empty box where you want the answer. Go to function, type in intercept, although it's there, you can see it's there, you just could choose it from there, but just showing you how to do it. Okay, I didn't choose it, did I? Oh man, back, apologize. Intercept, go. There it is, the intercept. Okay, known wise, we do the same thing. Go from C2 to C7, left click on it, left click on the X value in the box there, choose time 1 to 12, left click, hold down the clicker and drag it up. No, let's just do that again. I could have filled in the number actually. You could have also typed in A2 to A6. That's okay. And then when it gives you this answer, it's probably because it's some huge answer. Let's just, it won't let us do that. Move that open. Move that open. Oh, did I make a mistake there? C2 to C7, A2 to A7, you see? Got to be careful. So I'll just fill it in. It's the same problem we had before. There we are. So got to be careful with your data. And we'll decrease the number of decimals to 4. And that's the value, 2.269. Then we can go put in correlation. Correlation coefficient equals, I'll choose that empty square function, and we've got correlation coefficient. I can spell properly. Go, and it'll give you correlation coefficient. Returns the square of the Pearson product moment correlation coefficient through the given data points. And then Pearson's correlation coefficient, Fisher line test. But we want Pearson's correlation coefficient because that's the one we want to use. You say, okay, and this time it doesn't ask you for X and Y's, it asks you for arrays. So you can just go array 1 there, C2 to C6, A2 to A7, and you see, now I've already made a mistake here. I don't know why it keeps on stopping at C2 to C6. There, wow. Okay, and that's the correlation coefficient. We can adjust the decimals again to, and that's a correlation coefficient, and this is the correlation coefficient squared. And we can do it from a formula, or we can do it manually. So we can put in there R for correlation, it's normally the one they use. And we don't have a superscript and subscript in the menu, so we click on the font, that little arrow in the right bottom, and we go for superscript. Okay, put in the number 2 and that's squared, and from that we can now calculate it. If you want to calculate anything, you put in equals in the menu bar there, and we want to actually get the square of this value, so we'll put in C11, then we'll shift 6, which gives you the exponential function. 2 means squared, so it's C11 squared, and you push the tick and it gives you the right answer, but that normally means there's so many decimals. Let's see if it'll do it. Yeah. Okay. Dum, dum, dum. 2, go to 3, so it's exactly the same. So there's the R squared there. So you don't actually have to do this value, but at least, because it's on the graph, but at least you want to construct a decent graph, and this is how you can work it out if you weren't going to draw a graph. But the best is to draw a graph, because then you know what it looks like. So that's how you can calculate the slope. And then of course from the slope and the intercept and the y-axis, we can carry on and calculate a little bit later. We'll see the apparent volume of distribution for the drug. We can calculate the elimination rate constant and the half-life of the drug. So if you have any problems, give me an email. Thank you for your attention, and I hope this has worked.